Let's talk about scaling. What is scaling? Or to be more precise, what is scalability? Scalability is the ability to handle a growing number of customers, clients, users, requests, and so on and so forth. In other words, it is the ability to handle increased but also decreased workload or demand of our applications, of our system. Nevertheless, scalability, or what is scalability, is not what I'm going to talk about today. You already know that. What I do want to talk about are the types of scaling we can employ, how to automate it, how to do it in the first place. When we talk about scaling, typically we can depict it into two axes. We can talk about what are we scaling, and that's applications or servers, or we can talk about the direction of scaling, whether it is vertical or horizontal. Now let's go back in time just for a short while. So long time ago, we let our applications occupy whole nodes, whole servers. So vertical scaling, what I'm going to explain later, of applications was effectively vertically scaling servers by increasing the amount of memory or CPU, or moving applications from smaller to bigger nodes, bigger servers. Back in those days, and remember, I'm old, but back in those days when I was young, scaling was mostly a manual process. For most of us at least. Since that time, we got quite a few things. We got VMware that introduced virtualization to majority of companies. We got cloud, and cloud offered us services for scaling like AWS Autoscaling groups. We got OpenStack that allowed us to have cloud-like experience on-prem. We got managed services like Lambda or Google Cloud Run or Azure Container Apps. And all those are based on scaling principles. All those are scaling our applications one way or another to meet the demand. We also got Kubernetes, and Kubernetes is all about scaling. Maybe that's not the main theme. Okay, I'm exaggerating a bit, but a big part of Kubernetes story is how we scale applications, how we scale servers or clusters, how we scale the capacity of our system. So, what I want to do today is discuss the types of scaling we have and how all that works. I will be using examples in Kubernetes, but, and this is a huge but, the principles that I will show apply on any other platform. So imagine an application, a typical application, or maybe not that typical, but an application. And that application has some memory and some CPU assigned. It could be 1 GB of memory and 1 CPU, for example. So if we want to scale that application vertically, vertical means up, but also down, we do that by giving it more memory and more CPU. We could add 1 additional gigabyte of RAM and let's say 1 additional CPU. But that might not be enough, so later on we might add additional gigabyte of memory. And further on, even that might not be enough, so we might add it, let's say 4 gigabytes of memory, more than double the amount of memory assigned to that application, because there is increased demand for that application. And in this context, I'm assuming that the application can work with more memory and more CPU, and that makes it be faster, handle requests better, whatever the benefits are. Not all applications can be improved by adding memory and CPU, but some certainly can. And we continue like that by, let's say, add more CPU. Let's say half a CPU. It can be any number depending on what the demand is. And remember, it's not only about scaling up, but also scaling down, because even though at some moment application might need more memory and more CPU, at some other moment it might need less. So we might start removing the memory or CPU that is assigned to that application. Now you might be asking, hey, why would we remove memory and CPU? And the answer is relatively straightforward, so that we can free those resources for some other applications, because by the time the demand for this app goes down, maybe the demand for some other application will go up. If you're using public cloud, we have very good incentive to do that, because we are paying for what we use, And if we are using on-prem data centers, then the incentive would be to free memory or CPU for others when we do not need it. So vertical scaling is about adding or removing resources from an application in this context. In Kubernetes terms, vertical scaling is implemented at least on the basic level through VPA or Vertical Pod Autoscaler, which scales our pods vertically up and down. And it's not only about adding more memory and CPU for the sake of handling load better, but it is also about allowing Kubernetes to properly allocate resources. Because if we request from Kubernetes more memory than we need, then Kubernetes will reserve more memory than it needs to reserve for that pod in this case. So let's take a look at a simple example. I'm going to deploy my application by executing kubectl. The namespace is going to be production, and I'm going to apply something using customized, defined in customize/overlay/production. And you can see from the output that I got a service, a deployment ingress. There's nothing special, no scaling, at least not visible yet. Now let me describe the pod or pods that I deployed so that we see what's going on with requested resources and maybe limits as well. So I'm going to execute kubectl, namespace, describe pod, and that's the selector. Go. So here we can see that I specified certain amount of resources. I set the limits to be 0.1 CPU or 100 CPU milliseconds and memory to half a gigabyte or 512 megabytes. Those are the limits. That's the maximum that Kubernetes will allow for that application. But requests is what I expect that application to use, that pod to use. And it's set to 10 CPU milliseconds, which is almost nothing, and 1/4 of gigabyte of memory. Those are more or less random numbers, which I did not really base on data. I should have, but I didn't. But now let's see what happens if we plug this, if we combine this with VPA, with Vertical Pod Autoscaler. So here's the file. The file is defined in customize overlays VPA YAML, and it is a Vertical Pod Autoscaler that targets certain resource. And in this case, it is targeting the deployment that I already deployed, installed, and that deployment is called DevOps Toolkit. I'm setting the update policy and update mode in update policy to auto. I will comment on what options we have over there, and then let's move into resource policy because that's where the real magic is happening. Or to be more precise, where the limits of the magic are defined. So I'm saying, hey, you know what? Do whatever you think should be done in regards of memory and CPU with that pod, with the pods of that deployment, but do not go below 1 CPU millisecond or 1000 of CPU, and do not set less than 1 megabyte of memory. The maximum allowed is 1 CPU and 1 gigabyte of memory. And you should do the magic only based on CPU and memory. There could be others, but that's what VPA does out of the box. Now, before I apply that definition, let's talk about the modes. You saw that I set it to auto, but there are others. It could be recreate, which updates the requests over time. So recreate will be modifying memory and CPU of my pods, not constantly, but periodically. And that causes recreation of pods, because whenever we change requested resources or limits, Kubernetes will shut down that pod and create it again, because it might need to figure out where to run the pod with new specifications. It could be initial, meaning that VPA will assign resources to pods only when those pods are created. It could be off, which means that it doesn't do anything on pods, but it does give suggestions. And finally, it can be auto, which is what I'm using, which is the same as recreate today. Later on, we might see changes to auto, especially when restart free or in place update of pod requests becomes available, because that's coming in Kubernetes. And then auto mode might switch to that, because that would be awesome, right? How about modifying the requests of pods without restarting them, without shutting them down when that is possible? Now let me apply that definition by executing kubectl, namespace apply, and then customize, and the path to customize. And the service and deployment and ingress did not change, but vertical pod autoscaler was created. Now let's describe the VPA and see what we got. We got nothing or nothing interesting so far, so I will wait for a few moments, and while we're waiting, this is the perfect opportunity for you to subscribe to this channel, to like these videos, to help us beat the algorithm, and to join the channel if you would like to support it a bit more. It's price of a coffee a month. You can probably afford it. Sufficient amount of time probably passed, so let me describe VPA again. And this time we can see that we have lower bound, target, uncapped target, and upper bound. You can probably guess what it means from the names themselves. What really matters here is the target, which says based on current usage of that pod, CPU should be changed to 25 milliseconds and memory should be set to 26 point something megabytes. VPA was watching the pod, how it behaves, and that's what it deduced. It should be optimal amount of resources assigned to it. The situation might change in the future, and since the mode is set to auto, when the situation changes, then VPA will update the pods as well, the specification of the pods. And if we describe the pods just as before, we can see that the limits and requests changed. Requested CPU is now 25 milliseconds, CPU milliseconds. Memory is more or less 26 megabytes. No, wait, that's wrong. That's 260 something megabytes. I was wrong the last time. And limits changed to 250 milliseconds and half a gigabyte of memory. Now, what VPA did was two things. First, it changed requested CPU and memory based on current usage of the containers in that pod, and it changed the limits, but only proportionally to what was originally set. So it increased it proportionally as much as it increased requests. Okay, we're done with the vertical scaling of our applications, with vertical pod autoscaler. So let me delete what I did, and we move on. But before we do, let me give you a warning, a huge warning. Vertical pod autoscaler should not be used together with horizontal pod autoscaler or HPA on CPU or memory or any other metrics that horizontal pod autoscaler is using. And I'm yet to explain what horizontal pod autoscaler is, but once you find out what it is, then you should memorize it. Do not combine the two. Do not use the two together, at least not unless you have a very good reason to do that. And with that, we can move on to the next section, which is about scaling applications horizontally. Scaling applications horizontally is all about adding more replicas of that same application. At the beginning, we might run application with one replica, and then if we need more, if traffic increases or number of users increases or whatever happens, then we create a second replica of the application. And then the third, the fourth, the fifth, the sixth, the seventh, eighth, ninth, and so on and so forth. We create as many replicas as we need to handle the traffic going in or out of our applications. And the same thing goes in the opposite direction. When we need less replicas, then we remove them. As simple as that. So let me apply a manifest of my application. Just as before, I'm going to apply the manifest of application without any scaling baked in, and then we can observe what happens when we add scaling, horizontal scaling to the picture. So I will execute kubectl, the namespace apply, and then customize the path to where my application is. And you can see that I got the same things as before, service deployment and ingress, and I'm going to retrieve all the pods, and you can see that there is only one pod of the application running. Now I could change that situation by changing the deployment and specifying the replicas field to some other number, to 3 or 5 or 7, But that would be silly, because that would be me monitoring the application all the time and increasing or decreasing the number of replicas. That's just silly. That's a waste of my time. We can automate that, and we can do that horizontal scaling of an application in Kubernetes using HPA, or Horizontal Pod Autoscaler. So let's take a look at the definition that I'm going to use. It's stored in HPA YAML file, and it looks something like this. We're defining Horizontal Pod Autoscaler, setting the limits. What is the minimum number of replicas? What is the maximum number of replicas? 2 and 6 in this case. And we are targeting, referencing certain resource, which in this case, just as in the case of VPA, is the deployment called DevOps Toolkit. And finally, the last line says target CPU utilization percentage. That's the important one. That says, hey, you should scale this application up whenever it reaches certain threshold, in this case, percentage of CPU used, or you should scale down when it goes below the threshold. And in this case, it's set to 1%. No sane person would ever define scaling of an application based on 1% of CPU usage. But since I want to demonstrate easily how it works, I will put the threshold very, very low to 1%, intentionally to see you quickly how it works, instead of me trying to generate traffic, increase the amount of CPU usage, and so on and so forth. So do not do this yourself. This is only for the demo. So let me apply that by kubectl apply, customize, etc., etc., etc. We can see that HPA was created. And now we need to give it a couple of moments until it figures out what's happening. And while waiting, we're going to do two things. First, if you haven't subscribed already, and when I told you the first time, then you should subscribe right now, or join, or like the video, or whatever you're doing. Second, I should let you know that HPA supports only memory and CPU utilization as out-of-the-box metrics that we can use. I'm using today, right now, only CPU utilization, but you could combine it with memory. But that's not all. That's what comes out of the box. You can hook it up into other metrics where the amount of permutations you can do and the possibilities are endless. My favorite is to hook it into Prometheus and then query Prometheus for metrics and decide whether to scale up or down. You can do that. You probably know how to do that. Actually, if you're watching this video, you might not. And if you would like me to show you, to display, to teach you how to scale horizontally applications based on metrics in Prometheus, well, I can do that. Just let me know. Now let's take a look at the pods we have in the system by executing kubectl, etc., get pods, and we can see that now there are two pods. One that is 3 minutes old, that's the original one, and the moment I applied HPA, a second pod was created. HPA, Horizontal Pod Autoscaler, scaled our application to 2 replicas, and now it continues monitoring the metrics and checking whether CPU utilization is below or above or at the threshold or around the threshold, and then it will decide what to do next very, very soon. We can get information about HPA, high-level information, by retrieving HPA, and then we see that targets are currently at 4% utilization, even though I requested 1% as a silly threshold. The minimum number of pods is 2, the maximum number of pods is 6, and the current number of replicas is 2. That will change soon, since the target is still way above the threshold that I set. So let me retrieve pods one more time, and there we go. Now there are 4 replicas of the application. Simply HPA saw that it is still using more CPU than specified, so it scaled up one more time, and then one more time. Actually, it increased. It doubled the capacity. At the same time, it created 2 new pods. You can see that by the age. And then we wait for a while and wait for a while longer, and then retrieve HPA again. And we can see that the number of replicas is 6, and the targets are still way above the threshold. Now it actually increased to 6%, even though I want silly 1%. So let me retrieve the pods one more time, and now we can see that the number of pods is set to 6. There are 6 replicas of the application. It will not continue increasing beyond that, because that's set as the maximum number of replicas allowed. It will stay there for as long as the thresholds, the actual usage of CPU is above the threshold. If it ever goes down, if the usage drops, then it will start scaling it down by removing pods or removing replicas of the application. Now, to be honest, HPA is not the only way how you can scale your applications. There are dozens and hundreds of ways you can scale your applications horizontally, especially if you use managed services or if you create some other types of resources. If you're hosting your own Kubernetes cluster, you might want to check out Knative, which is partly about scaling but on steroids. It's absolutely amazing. Or you can use managed services like Azure Container Apps, which will do the same thing for you. It will scale your applications up and down. AWS Lambda is not using Kubernetes, but it is still based on the same principle, except that scaling horizontally is done for every single request. Now let's move on and go into scaling horizontally, but not applications, scaling nodes horizontally, scaling your servers, the capacity of your cluster horizontally. So, how does it work? What do we do with servers? On a high level, we have, let's go simple and say we have one server and then we deploy one application and then another application and yet another application or replica of an application to that server. And at one moment, we reach the limit and then there is no capacity available for yet another application or yet another replica of an application to be deployed to that server. So what do? We scale servers horizontally by adding additional server, additional node to the cluster. And then we keep putting applications there to the new server because now we have additional capacity. And if the number of applications, the number of replicas keeps increasing and we reach the limits again, then what do? Add another cluster, add another server to the cluster. And so on and so forth. We increase the number of servers, the number of nodes, and decrease them just as well, depending on the workloads that are running in those servers. So it goes up and it goes down. Actually, it's not up and down, it's left and right, because up and down is vertical scaling, which we are going to talk about later. Now, one thing you should know is that horizontal scaling of your servers results in additional servers, additional nodes that are the same as others. So typically, in most cases, out of the box, by default, when you scale your cluster horizontally by adding additional servers, new servers will be the same size as the old servers. It doesn't have to be, but in many cases, that's what it is. Now let me demonstrate how that works. Today I'm using GKE, I think. GKE already comes with Cluster Autoscaler. Other managed Kubernetes services also tend to come with the Cluster Autoscaler baked in. If not, you can install it separately. I already did that in advance, so what I want to do is just show you the effect. There is nothing to configure, really. I mean, there is, but not in this scenario, not when we're using out-of-the-box provided by the vendor type of scaler. So let me change the Horizontal Pod Autoscaler, not Cluster Autoscaler, Horizontal Pod Autoscaler slightly so that we can see the effects of having more replicas. And the only change I did was to modify the maximum number of replicas and set it to 100 so that Horizontal Pod Autoscaler can keep increasing the number of pods, the number of replicas, until it reaches the limits of the cluster that I'm running right now. So I'm going to apply that file, the whole directory, so that HPA is auto-configured or reconfigured. And now, soon actually, Horizontal Pod Autoscaler will increase the number of pods up to 100, and that will soon result in the limit of the capacity. Either there will be no space for my pods to run, or the cluster will increase in size in the number of nodes. So let me retrieve the number of pods, and what do I have so far? We got to the number of 10 pods, give or take. I need to give it more time because all those 10 pods are running. So there is obviously enough capacity for those 10 pods inside my current cluster. So let me fast forward a couple of minutes and then retrieve all the pods again. And now there are so many more new pods running inside my cluster. There are, I don't know how many, 50, 100, doesn't matter, many more pods. And I believe that my cluster could not handle all those pods. None of them are in the pending state. So either my cluster can handle all that or something else happened. So let me take a look at the number of the nodes I have in my cluster. So KubeCut will get nodes, and there we go. I had 3 nodes at the very beginning of this demo, and now I have 5. The cluster capacity increased horizontally, and that happened by adding 2 additional nodes, and that seemed to be the number that is required to run all the replicas, 100 replicas of my application. Now, scaling nodes might be caused by one of the 2 reasons. I mean, more than 2, but 2 common reasons. First of all, we might need to run more replicas than the capacity of the cluster allows, which is what I did right now, or that might happen by changing the requested memory and CPU, and that could be through vertical pod autoscaler. So vertical pod autoscaler might say, hey, I want to give more memory and more CPU to that specific replica or those replicas of the application. So not increasing the number of pods horizontally, but increasing the capacity of those pods or requested memory and CPU of those pods, and then cluster might not have enough memory, CPU for that, and then it might increase the number of nodes, scale itself horizontally. Now, one thing you should know about cluster scaling is that scaling up or not to the right, I think horizontally, works much better when we are adding nodes than when we are removing nodes, because when we remove nodes, we need to think about quite a few things like, hey, which pods should be evicted, which pods should not be evicted, what happens with those nodes, which nodes should be destroyed, and so on and so forth. So removing nodes is a bit trickier than adding nodes, but you should do both anyways, because you want to save money if you're in public cloud, and if you're not in public cloud, then you want to enable other clusters to use your capacity when you don't need it. Now let's talk about scaling clusters vertically, meaning not by adding more servers, but by increasing the capacity of the servers. And I will explain soon how that is not really likely to happen, not a good idea. But let's see first what happens when we scale horizontally. Going back to where we were, we have a server, and then we put one replica and another replica, we reach the limit, and then we create another server, and then we keep adding applications to that server, and then happens the unimaginable. Imagine that you want to deploy an application that not only has no available capacity in the current cluster, but is bigger than any of the servers themselves. So increasing the number of servers would not help if those servers are going to be the same as the other servers, because application needs more. It needs bigger machines. So what do we do then? Well, we combine horizontal scaling with vertical scaling. So we scale horizontally by adding another node to the cluster, but we also scale vertically by making that node, that server, bigger than it usually is. So it's unpractical really to scale servers at runtime, the existing servers, by increasing an amount of memory and CPU. But what does make sense is to combine horizontal and vertical and say, hey, I'm going to give you a new server, and that server is going to be bigger or maybe smaller than the other servers, because that's what you need right now. And you can easily see the effects of that type of thinking with quite a few services. For example, GKE Autopilot, Google Cloud GKE Autopilot does just that. It creates new nodes when we need them, it removes nodes when we don't, and those new nodes are tailor-made to fit specific pods. So if pod is big, server is going to be big. If the pod is small, server is going to be small as well. Another example is Carpenter, which allows us to do something very similar to what Autopilot does, but without being managed, by being self-managed by us, and today working only in AWS. You can watch videos of both, so go ahead if you're not familiar with them. Now, before I leave, I want to give you a couple of tips. So this will be brief, only the bare essentials. To begin with, beware of combining Horizontal Pod Autoscaler and Vertical Pod Autoscaler. If you can avoid using both at the same time, use one or the other unless you really know what you're doing. Otherwise, those two will be fighting for the same resources, for same memory or CPU or potentially some other type of metric. It's not a good idea unless you really need it. Second, if both Horizontal Pod Autoscaler and Vertical Pod Autoscaler can do the job that you need it to do and you need to choose one of those two, choose Horizontal Pod Autoscaler. I, at least, tend to scale my applications horizontally whenever needed, whenever they are replicated, and use Vertical Pod Autoscaler mostly on applications that cannot scale horizontally, usually stateful applications, right, that cannot be scaled horizontally. Third tip, no matter how you scale your applications, you need to scale the capacity of your cluster as well. The ideal combination, without going into additional tools, is to combine Horizontal Pod Autoscaler with Cluster Autoscaler and then sprinkle it with the Vertical Pod Autoscaler only for the applications that do not scale horizontally. Thank you so much for watching. See you next time. Cheers.